Today, we are going to go over slope and slope-intercept form. So these 16 problems will deal primarily, the first couple will be finding slope when you're given different pieces of information. In this example, we're given a graph and we're given a line with an infinite number of points, but two of those points are on grid lines. So we want to choose those. We like those better than other ones. For instance, if we had, let's do this, let's make it a little bit smaller. If we had this point, that's good. We can use that point because it's on a grid and we know its location. We know its coordinate. But I wouldn't use that one because it's not on a grid. It's not a whole number. I know that this coordinate is, this one is -2, 1, 2, 3, 4. So that is -2, 4. So I could use that. We can use the blue ones. The blue ones are on. And so we're going to say, hey, slope, remember, is rise over run. And rise, we go up, down, and run, we go right to left. Up being positive, down being negative, right being positive, left being negative. So we're going to look, we're going to take these two blue ones. So I'm going to start with this blue one. It doesn't matter, but I'm just going to choose that one. And I'm going to see, how do I get to the other point? By going up and down. I can only go up and down. So to get to this point right here, starting with this blue one, starting with this one, I need to go down 1, 2. So I'm going down 2. I have to go down 2. And now to get to the other point, I need to go right 1, 2, 3. So I went down 2, right 3. So down is negative. So down 2 equates to -2. And right is positive, so right 3 would be +3, so my slope is -2/3. I can write -2/3, I can write -2/3, or I can write 2 over -3. All three of these are the same values. And you ask, hey, Mr. Mack, how is 2 over -3 the same slope? Well, 2 would be +2. And in slopees, that would mean up 2. And -3 would be left 3. Oh, sorry. That's -3 would be left 3. So if we go to that point, if we start at this point and we go up 2, 1, 2, and then left 3, 1, 2, 3. Look at that, we still end up on the line. So that's why the slope can be in any way. We can go from this point to this point. We can go from this point. We can go from this point to this point. It doesn't matter which 2 points, they just have to be points on the line. And no matter where on that line, the slope is going to be -2/3. It's always going to be the same. So that's a nice way of finding slope. So I'm going to start at this point. I'm going to go to this point. I'm going to go down 1. And then I'm going to go 1, 2, 3, 4, 5, 6, 7. I'm going to go left 7. Down 1 is -1. Left 7. That was not left, Mr. Mack. Did you see that? Did anybody just catch that? That's right 7, which is +7. So the slope is -1/7. I almost made a mistake there. I almost made a boo-boo. Good. Let's check this one. I'm going to go from this point to this point. So up, down first. I'm going to go up 1, 2, 3, 4, 5, 6, 7. Up 7. And then I'm going to go right 1, 2, 3, 4. Right 4. Up 7. Right 4. Gives me 7/4. I'm not going to write that as a mixed number. Okay, I'm always going to keep that as an improper fraction. And let's look at number 4. So I'm going to go down 1, and I'm going to go right 1. Down 1, right 1, and I would have to simplify that. That is a slope of -1. Now, the other type that they will give you is they will give you 2 points that are on the line. Notice we're using 2 points that are on the line. That's point 1, point 2. But this time they just give us the coordinate. So we're going to utilize this formula. This is the formula to calculate the slope. And when we see y sub 1 and x sub 1, we're talking about a coordinate. And x sub 2, y sub 2, this is point number 1. This is point number 2. This is the x value in the first point. This is the y value in the first point. This is the x value in the second point. This is the y value in the second point. We're going to name this point 1. That's a horrible way of writing point 1. This is going to be point 1. This is going to be point 2. It doesn't matter. It could be the other way around, much like it didn't matter if we started with this point and went to that point or whatever. So we could start with either one. Either one can be point 1, but for purposes, so this will be my x value in my point 1. This is my y value in my point 1. This is the x value in point 2. This is the y value in point 2. All coordinates are written x comma y. So we're going to transcribe. We're going to look, and it says, give me the y2 value. The y2, the y value in the second point, is -20. It's the y value in the second point. Minus, that's this part, minus the y sub 1 value. The y sub 1, that's the y value in the first point. So the y value in the first point is -11. And this is where most students make their mistake with the writing. This is your y sub 2 minus your y sub 1. They confuse those two negatives. So make sure that you write this negative. You have to be able to write that negative. And then x sub 2, that's my x value, is -9 in my second point, minus my x value in my first point, which is -14. So this is a real tricky one to start off with. We're going to rewrite this because I have double signs. So I have -20 plus 11 over -9 plus 14. So -20 and positive 11 is 9, -9, excuse me. -9 plus 14 gives you +5. So my slope for the line containing the points -14, -11, and -9, -20 has a slope of -9/5. So this is x1, y1. This is x2, y2. We have y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Remember, it's rise over run. Rise, we go up, down. That deals with the y-axis. Up, down is the y-axis. Hence why you have the y's in the numerator here. Over the run, and run is right, left. That's the x-axis. When we go left and right, that's going to be the x-axis. That's why the y's are in the numerator, the x's are in the denominator. So my y sub 2 is 10 minus my y sub 1, which is -1, over my x sub 2 is 5 minus my x sub 1, which is 1. That's going to be 10 plus 1, which equals 11, and 5 minus 1 is 4, so my slope is 11/4. X sub 1, y sub 1, x sub 2, y sub 2, second point, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Y sub 2 is 12 minus negative 4, and negative 14 minus negative 20. 12 plus 4 over negative 14 plus 20. That's a horrible 20. 12 plus 4 is 16. Negative 14 plus 20 is 6. Can't leave it like that because we can reduce it. What number goes into 16 and 6? 2 does. 2 goes into 16 8 times. 2 goes into 6 3 times. So the slope of the line containing those 2 points is 8/3. X sub 1, y sub 1, x sub 2, y sub 2. Y sub 2 minus y sub 1, x sub 2 minus x sub 1. Y sub 2 value 0 minus negative 16. X sub 2 is 8 minus negative 8. 0 plus 16, 8 plus 8, 16 over 16, which equals 1. Slope of 1. All right, now we move on to, oh wow, I started you off with a real toughie. So find the slope of each line. Well, we need to make sure that it is in slope-intercept form, which isolates y. Y is isolated. Y is isolated. It's by itself. We want to solve for y because in this case, when y is by itself, the coefficient of x is going to be the slope. M equals the slope. And b is going to be the y-intercept. So in this, oh, I should have changed that. So we only want the slope. I should have asked for the slope and the y-intercept. That is my bad. I should have changed those directions. Oh well. So it wants the slope. What do we notice about this is that we have one variable. This is one of those trick ones. There are situations where you should notice. And the situation is when you have y equals 3x, or you have y equals 1/4 x minus 2. Each of these, we have two variables. When we have two variables, we can pull out the slope and the y-intercept. It will always be a slope. There will always be a y-intercept. When we have something like y equals 6 or x equals negative 3, we notice there's only one variable. And when there's one variable, that means that it's going to be either horizontal or vertical. Either horizontal, it's going to be a horizontal line or a vertical line. And those situations, so these are going to be lines that have slope, right? You'll see it like that, or the line will be like that. That's a negative slope. The black one's a positive slope. When we have these, when we have only one variable, you're going to either have a horizontal line. Notice it goes through the y-axis. So this one, y-axis, at 6. And this one, it's going to go like this. It's going to go through the x-axis at negative 3. So little tricks in understanding. Well, when we look at the one that goes through the y-axis, that's going to have a slope. I don't want it in red. This is going to have a slope of 0. So this has 0 slope. It says 0 slope, and it has a y-intercept of 6. This one, do we want to ski that slope? This has no slope. Very different from 0. This has no slope, and notice it has no y-intercept because it doesn't go through the y-axis. So notice this equation has one variable, so we should be aware that it's either going to be horizontal or vertical. And in this case, it's x, so it's going to go through the x-axis, so it's going to be straight up and down. And this is going to have no slope because we don't want to ski that slope because it's going to be a vertical line. This one is more traditional. It's in the y equals mx plus b format. So the coefficient of x, it's the number in front of x, is going to be my slope. So the coefficient of x is negative 1/4. So my slope is negative 1/4. Now I'm going to go back to this because I know it doesn't ask for the y-intercept, but I will be asking you, and we just need to know that there is no y-intercept. On the assessment, I will be asking you for both, the slope and the y-intercept. But in this homework, I didn't do it. So the slope is negative 1/4, and the y-intercept, just for technical purposes, the y-intercept for this line is going to be 1. Perfect. And it just is asking you to find the slope and the y-intercept. I know it doesn't technically say that, but we're just finding it. We're not graphing yet. Okay, so that's good. And here we go again. We should notice, oh, this one's interesting. This one's different because there's only one variable. One variable, and it's the variable y, so we know it's going to go through the y-axis at 5. So it's going to be a horizontal line. And we know horizontal lines have a slope of 0. That's a bunny trail. It is a slope of 0. It's 0 value. And then we know that the y-intercept is going to be 5 because we can think of this equation y equals 5 as y equals 0x plus 5. Because it's isolated for y. We know it's y by itself. And then we don't see an x value. Well, we don't see an x value because there's a 0 in front of it. So that's why the slope is 0 and my y-intercept is 5 because that's my constant. It's a nice way of thinking about it. Here we go. The slope is the number in front of the x value, which is negative 3. And then my y-intercept is going to be 5. Now, we're asked to graph this. So we want to graph this, and graphing it, it's in slope-intercept form. We like that. We like the fact that it's solved for y. So we were able to pull out the y-intercept. The y-intercept is the constant. What's the number? Is negative 4. And we know what the slope is. The slope is negative 1/2. Okay? So my slope is going to be the number in front of the variable. It's not going to include x. X is not in there. It's just the number. Good. So what do we plot first? We always need a point. We don't know where to go to use my slope. We don't know how to go down 1, right 2. We have to do that from one point to the other. So we must plot the y-intercept first. Plot that first. So y-intercept, it's going to cross the line, the y-axis, at negative 4. So I'm going to make a dot at negative 4. Now I'm going to use the slope. Notice that negative is right in between. It's not in the numerator. It's not in the denominator. So I can either put it in the numerator or I can put it in the denominator. So in slope e's, negative 1 would be up, down. So negative is down, down 1, and the denominator 2 is rise, or is run, left, right, left. So positive 2 is right. So I can go down 1, right 2, down 1, right 2, or that's my rise, so up, down, positive is up 1, and then -2 is left, right, or right, left. Negative is left, so I could go left 2. So I could go up 1 and left 2, up 1 and left 2. And notice it creates that line for me. So they all connect. That's the cool thing about it, is it doesn't matter where you put that negative. We just need to be aware that there's only one negative. So there's one negative, there's one negative, there's one negative. Can't put two negatives because then it would become a positive. So when we have this starting slope of -1/2, you need to either put it in the numerator or the denominator. And let's make sure we have arrows on our line, and then you need to give me the coordinate of 2 of these points. So I need to see the coordinate of at least 2 points. That intercept is 0, -4, and then I'll use this one, which is 2, -5, which is this point right here. Okay, and then you're done. So let's move on to the next one. We're going to find the y-intercept. Y-intercept is 3. The slope is going to be 5/3. So we plot our y-intercept at 3, and then my slope, 5, means up 5, right 3. Right is positive. This is +5 over +3. So we're going to go up 5, 1, 2, 3, 4, 5, and then right 3, 1, 2, 3. So that point is right there. Or the opposite of up 5, right 3 would be down 5, left 3, because down is negative and left is negative, and we know what -5 over -3, 2 negatives make a positive, so we still end up with that proper slope, 5/3. So if I went down 5, 1, 2, 3, 4, 5, and left 3, 1, 2, 3, I would get to this point, which still gives me the same line. So I need to write 2 coordinates. That is 0, 3. This one would be 3, 3, 8. And I just counted, right? We were at 3, 4, 5, 6, 7, 8. And then to the right, 3 would be 3, 8. This coordinate is -3, -2, if you wanted to use that one. You only have to list 2, but you have to give it. Even if you go off of the grid, you still got to be able to calculate what those values are. Well, I like this. What do we notice? Well, that's going to be, what's my constant? What's my y-intercept? It's +0. We don't see it, so it's 0. So my y-intercept is going to be 0. My slope is going to be -3 over 2. I'm going to put the negative in the numerator. So that's down 3 and right 2. I always have to remember, slope is rise over run. Rise is up, down. Run is right, left. Up is positive, down is negative. Right is positive, left is negative. So when I have a -3, I'm going down 3. When I have a +2, I'm going right 2. So I'm going to plot my y-intercept, which is 0, and then I'm going to go down 3, 1, 2, 3, and right 2. And I make that dot. I'm going to write my coordinate, 0, 0, and this is 2, -3. Let's look at the last one. Again, red flag, ding, ding, ding. What do we notice? We only have one variable, and it's the variable x. So it tells me that it's going to go through the x-axis at -3. Here's the x-axis. It goes through the x-axis. Every x value is going to be 3. It's going to be a vertical line going through the x-axis at 3. So I can pick any point. Why did I pick this one? I could have picked this one. And it should technically be on there, a little bit better. So let's write the coordinates. This is going to be -3, 0. this point will be -3, -4, or any other point on that line that you want to be on the grid. You could have chosen -3, 2, or any other one. Cool. And my slope is no slope. I don't want to ski that. And there's no y-intercept. You don't have to state this, but that's understood. So hopefully that helps you. Those are all the solutions, checking against my work, because Mr. Mac is not perfect, and sometimes we make mistakes. I hope, let's look at number 10. I don't remember 10 being -1/4. Let's check it out. Yeah, slope of -1/4. All right, Mr. Mac was right. Have a good one.